All right, example number 2 in tonight's notes. Let's take a look at this system. It looks like this is going to be set up pretty nicely for us to use elimination. We've got 3x minus 2y is equal to 12, and negative 3x plus 2y is equal to negative 6. So when we add these two equations together, 3x plus negative 3x is 0. Negative 2x plus 2, or negative 2y plus 2y is going to be 0. I'm choosing all the wrong pens here. So we've got 0 plus 0, and 12 plus negative 6 is going to be positive 6. So we've got 0 equals 6, which, uh-oh, where do variables go? Well, that's not really actually important. We don't really care where our variables went. Here's the bigger deal. When we add these equations together, we get this statement. Is this statement always true or never true? It's never true. This is never true, right? And the value of x and the value of y don't affect whether or not this is true. This is simply never true. What that tells us is the combination of those two equations, the combination of those two restrictions on what x and y can be, results in something that can never be true, which means this system can never be true. Well, a solution is a point that makes a system true. It makes both equations true. Since this system can never be true, this system has no solutions, right? Algebraically, we can tell we have no solutions because we arrive at a statement, right? Namely 0 is equal to 6, that is never true. 0 is never equal to 6, which means that our system can never be true, right? Graphically, the way that we can see that we have no solution, well, look at the two lines, the two sets of solutions here, right? They're perfectly parallel, which means they're never going to intersect. If they never intersect, there's never going to be one point that's a solution for both of these equations. There's never going to be one solution that these two equations have in common. So we can see from the graph that our system has no solutions because the lines that represent the solutions to both, or maybe should I say to each equation never intersect. There are some other ways you could say that, and you should know this from geometry. You could say that the lines are parallel. You could also say that the lines have no points in common. And that's a thing worth understanding, because if they have no points in common, what that's saying is that the solutions for each of these two equations have no solutions in common.